Okay, the quiz asks you to do these operations, okay? Add these fractions and subtract them. Now, I'm gonna do them over here because I want to do these things in complete. Okay, you got 5 complete detail, 5/8 plus 7/2. Your common denominator, least common denominator is 8. Okay, so. And everybody seems to understand that, so I'm not gonna. Talking instead of thinking about what I'm doing. So I did the 5/8, what I was going to do to 7/2. Okay, it's 5/8 plus 7/2. And I'll write it this way, times 4/4. And now the denominators are going to match. And I multiplied by 4/4, which doesn't change the value of 7/2. It just looks different. It's going to be 28/8, but 28/8 is exactly the same thing as 7/2. Okay. You divide both numerator and denominator by 4, you simplify it down to 7/2. And the reason that works is because 4/4 is just 1. So we've just essentially multiplied by 1 here. And I realized that I need to move the board over. Okay. And that equals 5/8 plus 28, 27/8, which is 5 plus 27 over 8, or 32 over 8. That can't be right. 28 over 8. Would you let me do that for? Okay, let's make that right. Move out those smudges. Okay, it's 28 over 8. 33 over 8. 28 over 8. Down here, it's 33 over 8. And you know that. Then you could write that as 4 1/8 if you want to, right? Everybody get that? I bet you did. I haven't even really looked. Okay. Common denominator here. You can always get a common denominator if you multiply these two numbers. Okay. But up here, if you multiply two numbers, you get 16. You would have ended up with 66 over 16, which would then have to be reduced to 33/8. Okay, so we use the least common denominator. I assume you know what that means. Least common multiple, least common denominator. Okay, so 3/4 plus 2/3 is what? Well, our common denominator is 12. In order to get a denominator of 12 here, we have to multiply 4 by 3. So we take our 3/4 and multiply it by 3 over 3. So that our 4 is multiplied by 3. Multiplying by 3 over 3 is just 1. That ensures that we don't change the size or the value of that fraction. Okay. And then we have 2/3. And we're going to have to multiply the denominator by 4 to get the common denominator of 12. So we have to multiply the numerator by 4 as well. And that's 9 over 12 plus 8 over 12, which is 9 plus 8 over 12, which is 17 over 12. I think maybe I did that one right all the way through. Okay. So down here, 4 9s minus 7/12. Hey, what's the least common denominator? And you could multiply 9 by 12. Okay. You do that, you get 96. You could use the denominator of 96, but we want to use the least common denominator. Now, what we do at this stage is we a little window here. We do the prime factorization. Did Open Math mention prime factorization when they did this? Nobody. Nobody has seen that. Okay, but it's simple. To get the prime factorization of 9, you know what a prime number is? Everybody know what a prime number is? Number that can't be divided by any whole number. Okay, so you take the smallest prime number that goes into 9. That's 3. Well, you divide 9 by 3, your remainder is 3, so that 9 equals 3 times 3. Very simple. Okay, and that's a product of primes. You can't break those down anymore, so that's broken down as much as possible. Okay. Now I'm going to actually write it out for 12. Okay, so we're going to look at it like this. 12. What's the smallest prime that'll divide 12? Show me with your fingers. What's the smallest prime number? You divide 2 by any other number? Now, all the other primes are odd because any even number can be divided by 2, right? So all the even numbers after 2, you don't even consider them. They're not prime. So that's why you were saying 3. You knew it wouldn't be even, except you got to consider that, yeah, you can't divide 2 by anything else. Okay. So you divide 2 into 12 and you get 6. So 12 is 2 times 6. When you divide like this times this equals this, right? That's what division means. Okay. Then what smallest prime that'll divide 6? Show me with your fingers. Smallest prime that'll divide, what's the smallest prime? Will it divide 6? Okay, so you divide 6 by 2. And you get 3. Okay. So 12 is 2 times 2 times 3. And you multiply that out and see that it's true. Okay. You can always do that. So if you had really ugly numbers down here, you can always do prime factorization. I give you 338. It's divisible by 2. Okay. Then you check other primes. Okay, well, something you would ideally have seen. We can't spend too much time on it. You might well see it in your 161 course. So you want to make sure you've at least seen it. Okay. Okay, so what that is, what's the least common multiple? Well, the least common multiple's got to have everything in it that this one has. It's got to have everything in it that this one has. So the least common multiple needs 2 times 2 times 3. Okay. Now, let's look at 3 times 3. We got a 3 down here. Yeah. Have we got 2 3s down here? Oh, so we need another 3. Now that multiplies out to 36. And I saw a lot of 36s in your paper, so I know that you got that. This is a process that'll get it when your arithmetic starts getting away from you, when the numbers get really big. Okay. So it's an important process. Review the video if you need and see if you can apply it to some of the problems you've done. If you have time, or especially if it comes up in your pre-calculus class, that ought to give you a privilege. Okay. So this is going to be 4 over 9. Now 9 is your 3 times 3. We have to multiply by 2 times 2, or to get 36, we're going to multiply 9 by 4. Okay. So we do 4 over 4. and 7 over 12. 12 goes into 36 3 times. So we're going to have to multiply 12 by 3. And of course, we've got to multiply the numerator by 3. So we get 16 over 36 minus 21 over 36. And that's negative 5 over 36. And I believe everybody pretty much got that. At least the process looked good. I didn't even affect the answer. Okay. Because y'all tend to write kind of light. It's a little hard for me to see it. And I wasn't bright enough to put on my glasses before I looked. Okay. Well, let's do over B plus C over D. We'll talk about this. Can you tell me what the common denominator should be? Okay. The common denominator can always be obtained. A common denominator can always be obtained by multiplying the two denominators, right? It's CD. No, it isn't. It's BD. Okay. So what would I multiply B by in order to get BD? I have to multiply by D, right? We've got to multiply by D to get the common denominator. We multiply the denominator by D. We multiply the numerator by D, so that we're multiplying by 1. And D over D is 1. Okay. And then we do C over D times what? Got to multiply by what here? Show me with your fingers. Make the letter. What do I have to multiply by D in order to get BD? Well, to get BD, we better multiply D by B. So we multiply by B. And we multiply the numerator by B. Okay. And this comes out then AD over BD plus CB over BD. And then you just add the numerators, AD plus CB over the common denominator BD. The process is exactly the same as what you do with numbers. Now, I'll say if you've worked all your homework, but doing all the steps, and most of you did all the steps. If you didn't, you really probably want to rewrite some of these problems doing all the steps. So it's less weird to you when you have to do it later with symbols, okay? And the symbols get a lot more complicated. Instead of an A, this might be x squared minus 3x plus 7. This might be 2x to the 4th plus 5, okay? You're gonna have to be able to keep your wits about you and do it, which is why we've taken time here to make sure we understand how to add simple fractions with numbers. Okay, because you're going to have to use those principles later on in the course, and it's usually a stumbling block for people. That's why we included the assignment here. Okay, so make sure you understand in detail how to work these out. If you do, it'll be an easier transition when you do this. Okay, all right. Okay. Inverse functions. I'm going to ask you to make a table. I wouldn't do that. -2, -1, 0, 1, 2. Okay. What do you get for y equals 2 to the x? Okay, so we can make this table easily. And one of my big objections to the way open math does the basic functions, the toolkit functions or whatever, is they say use a calculator. I think that is egregiously terrible. Not maliciously, egregiously. And I think they do that because nobody knows the rules for negative exponents. Nobody knows how to do the arithmetic. So everybody uses a calculator. That's because nobody's ever done the arithmetic. You don't understand these functions unless you know the arithmetic, okay? You can evaluate them on a calculator and you can get the shape. You forget it, you go back, you do it again. You forget it, you do it again, okay? And if you do it enough times, maybe you remember for a short time, but you walk out of the course and you never remember it again. Until you need it later. Then you got to start all over. You learn how to do the arithmetic. Okay, first of all, I'm going to make a progression here. 2 to the 5th, you can easily calculate as 32. 2 to the 4th is 16. 2 to the 3rd is 8. 2 to the 2nd is 4. 2 to the 3rd is 2 to the 1st. Come back up, is 2, right? Okay. Now, if I just showed you these numbers, could you tell me what the next number in the sequence would be? How does this number compare to this? Well, let's go easy. How does this number compare to this one? It's half, right? And this is half of this. This is half of this, this is half of this, this is half of this. But what's the next number down here? Show me with your fingers. Well, if every number is half of the one before it, what's half of 2? It's 1. What's half of 1? It's 1/2, right? Okay, write the next 3 numbers in this sequence right here. What's half of a half? It's a 4th. Let's make sure we understand why. Here's 0 and here's 1, right? If we divide this in half, what's that number? Well, it's a half, isn't it? Why is it a half? Because it takes 2 of them to make 1. What's half of a half? We can do it here. We can do it geometrically. This is half of a half, right? Now, how many of these does it take to make 1? Show me with your fingers. How many of these does it take? 1, 2, 3, 4, right? It takes 4 of these to make 1. It takes 2 of them to make a half. It takes 2 halves to make 1, right? Okay. Now, if you don't understand this very clearly, and I think not everybody does, you want to review this part of the video. Okay. We're not that far into it, probably between 10 and 15 minutes. Okay. Should be easy to find. Just click through until you start seeing this, and pretty soon you'll see this. Okay. So this is 1/4. Half of 1/4. Well, we divide 1/4 into 2 and we get this. Now, it takes 2 of these to make a 4th. And how many 4ths does it take to make 1? It takes 4. So it takes 8 of these to make 1. So this is 1/8. I don't have room to do the next one, but you see what's happening. The denominators go 2, 4, 8. What's next in that sequence? 16. Okay. So we could go down to 1/8, 1/16, 1/32. Okay, well, what am I going to write? 2 to what power comes after this? What's the sequence? It goes 5, 4, 3, 2, 1. What's next? 0. So this has to be 2 to the 0. And we keep going down by 1. What's the next number? Counting backwards, 0, -1, -2, -3. So finish the table. You only went down to here, that's okay. If you get that far, you know what you do. Next. Oh, heck. Go ahead and do that. Okay, now I don't know where I stopped recording. This sequence of numbers is totally obvious. Here's an explanation. Of why these numbers are what they are. I hope that's in there, but if not, if you take the interval from 0 to 1, cut it in half, you get 1/2. Cut that in half, you get 1/4, because it takes 1, 2, 3, 4 of these to make one of these. Okay, cut that in half, and you get 1/8, because it takes 2 of these to make a fourth, and 4 of these to make one. That gives you 8 of these. So that's why these numbers are what they are. Some people had trouble calculating these. Okay, we really need to understand that picture. Then you can take this whole sequence, and what's a sequence of powers of 2? It's 5 down through 1. What comes after 1 if you're counting down? 0. You're counting down, you get -1, -2, -3, -4, -5. So we get 5 all the way down to -5. Very simple sequence. And each of these numbers is half of the one before them because of this. It leads us to the rule that a to the negative b is 1 over a to the b. So if x is -1, y is 2 to the -1, and 2 to the -1 by this rule is 1 over 2 to the 1. 1 over 2 to the 1 is 1/2. If x is -2, 2 to the x is 2 to the -2. By this rule again, it makes sense because that's 1 over 2 squared, or 1/4. Here are the points on a graph of the x squared function. Now, this is the way we constructed it. We constructed this without doing any calculations in my class. If you're in another class, you don't have to worry about that. You just plot these points on a graph. Well, okay, this is the exponential function. Well, it is, never mind. Okay, you have 2, 4. 1, 2 is here, 0, 1 is here, and all the way back to -2, 1/4, -2, 1/4. Okay, now we can sketch that on a graph, and implicitly now, here's x equals 1, here's 2, x equals 1, x equals 0, x equals -1, x equals -2. What I ask you to do now is switch the coordinates in this. So I can do that here. If I switch the coordinates, 1/4 goes here, 1/2 goes here, 1 goes here, 2 goes here, and 4 goes here. -1 goes here, -2 goes here, -1 goes here, 0, 1, 2. Do we understand? I've just switched the numbers. Okay. If I graph these points, then I've got to have 1/4 -2. Now, sketch yourself a graph like this. Make sure these lines are equally spaced. Sketch this graph, and then see if you can find the point 1/4 -2. And also, like here's 1, here's 2, and here's 4. I'll label that y equals 1, y equals 2, y equals 4. We don't need y equals 3. We're not going to need 3. So I don't bother to label it, but of course, I've got to skip some space between y equals 2 and y equals 4 because y equals 3 is really there. We just haven't drawn it. Okay. So where's 1/4 -2? And if that gives you trouble, see if you can find the point 2, 1. That one's easier. Let's just see if we can find these 2 points on the graph. And don't take a lot of time to sketch the graph. Make it nice and even to the extent that you can, but you don't have to be meticulous. We don't have class time to wait for everybody to sketch a meticulous graph. Let's be clear about what we're doing. We've got this table. Okay. The numbers that we have in the first column are 1/4, 1/2, 1, 2, and 4, right? Okay. I said, take this column and put it over here. Okay. And just the numbers. You don't have to do the calculations. Calculations are done. You've got the numbers. So you're going to put 1/4, 1/2, 1, 2, 4 here. Okay. This is the inverse function. Okay. And what are you going to put here? We put the numbers in this column. Do they match? Are these numbers the same as these numbers? Yeah, they sure are. Okay. So now the question is, if you got this graph, and most of you have it, can you locate the point 2, 1 on this graph? If you can, put a dot there and label it with the coordinates.